All right, in this video, we are going to work through the following problem. It says compute the exact value of sine of pi over 12. So again, exact value by that, they mean not a decimal approximation, right? They want the exact value with, as fractions involving roots and those sorts of things. So normally what we would do when we go to calculate the exact value of a trigonometric function, right, we would think about the unit circle. But if we look, right, pi over 12 is not on here, okay? So what I'm going to have to do is to express pi over 12, in this case, as a sum or difference. All right, in this section, we are studying the sum or difference of the sum and difference identities, right? So what I want to do is to write pi over 12 as a sum or difference of angles, one of these special angles that's on the unit circle. Okay, there are lots of ways to do that. The way that I'm going to do it is to write it as pi over 4 minus pi over 6. Now you might say, well, how did you know how to do that? Pi over 4 minus pi over 6. Well, from experience, I know how to do that, but one way to think of it, right, or maybe an easier way to think of it if you're not used to thinking in radians, is you might have to, kind of check yourself with using degrees, right? So if I look, pi over 12, if you convert that to 2 degrees, right, that would be 180 over pi, right? You would multiply it by, and the pi's cancel out, and 12 goes into 180 15 times. So that would be 15 degrees. We're trying to find this number that we get, the sine of pi over 12, will be the same as the sine of 15 degrees. And so thinking about it in that way, it might be easier for you to find two angles that are special angles, in other words, angles that are labeled on the unit circle whose sum or difference is 15. And there are a lot of them, right? 45 minus 30 is sort of the first one, right? 45 minus 30 will come out to be 15. But you could do 60 minus 45, or 135 minus 120, 150 minus 35, and so on and so forth. So there are lots of different ways you can do that, okay? All right, so again, it might be a little bit easier for you to work these problems initially if you think about them in degrees, even though this is in radians here, all right? Okay, so one way to check yourself is to just go ahead and subtract pi over 4 minus pi over 6 and make sure that you get pi over 12. The LCD, right, would be 24, okay, or no, 12 rather. That's the smallest number that 4 and 6 both go into. When you change pi over 4 to 12ths, right, that would be multiplying top and bottom by 3. And when you change pi over 6 into 12ths, you would multiply top and bottom by 2. Right, so you get 3 pi over 12 minus 2 pi over 12. And that comes out to be pi over 12. Okay? All right, so we're on the right track here. So what we want to do, since they want the exact value of sine of pi over 12 and it's not on the unit circle, we are going to do sine of pi over 4 minus pi over 6, like that. Okay, and that's going to be good because then we can use the difference identity, the one for subtraction. Okay, and we know pi over 4 is one of the special angles that's labeled on the unit circle, and so is pi over 6. All right, so let's look at the difference formula for sine. It's right here. Okay, so that's going to be sine pi over 4 cosine pi over 6 minus cosine pi over 4 sine pi over 6. All right, so we're using this identity right here. Pi over 4 is playing the role of x, and pi over 6 is playing the role of y. So we get sine of pi over 4 cosine of pi over 6 minus cosine pi over 4 sine pi over 6. And that's what we have here. Okay, and so now what we would do is just find the exact values of all of these trigonometric functions, and these are easy because they're all on the unit circle, right? So the sine of pi over 4 is square root 2 over 2. The cosine of pi over 6 is square root 3 over 2 minus square root 2 over 2 for the cosine of pi over 2. And then sine of pi over 6 is 1/2. Right, and again, we can find all those values on the unit circle, right, at pi over 6 and pi over 4. Okay, and so now what we want to do is just simplify this as much as possible. On this one, square root 2 times square root 3 is square root 6. And on the bottom, multiplying the bottom, 2 times 2 is 4. And then we need to multiply these two fractions. So multiplying across the tops, square root 2 times 1 is square root 2. On the bottom, 2 times 2 is 4. And so that's the final answer on this one. You can write it as a fraction, single fraction too, if you want. But either of those should be fine for the Newton problems that we are doing for homework.